The amount charged formula is used to calculate call charges in the system, applying both to the cost paid to vendors, based on destination sets and routing parameters, and to the revenue generated from customers, based on tariffs and rates. Understanding this formula is essential for analyzing call profitability and working with key features such as loss protection, margin-based routing, and least cost routing. In this video, we will break down the formula step by step, explaining each parameter to help you understand how call charges are calculated and how they impact routing decisions and profitability analysis. In Sippy Softswitch, a call is segmented into multiple intervals, and each interval is priced separately. This chart illustrates the general structure of time segmentation and the corresponding pricing. To calculate call cost, the system uses the individual parameters of the route selected according to the routing policy, along with the general parameters of the destination set to which the route belongs. Call duration is obtained from the vendor call records, and the amount charged formula calculates the amount that the Sippy operator pays to the vendor. To calculate call revenue, the system uses the parameters of the selected rate and the account's tariff, obtains call duration from the customer call records, and applies the amount charged formula to determine the amount that the Sippy operator charges the client. Before we dive into the interval calculations, it's important to clarify a few assumptions. All parameters in this formula, grace period, free seconds, interval 1, interval n, price 1, and price n, must be non-negative, and the system validates these values when you enter them and click Save, displaying a warning if any value is invalid. Call duration cannot be negative, so this formula only applies to non-negative durations measured either in the number of intervals n or in seconds. Now that we understand the overall structure of call charging, let's see how these rules are applied in practice. First, let's examine how the grace period works. This period allows a caller to confirm that the call quality meets expectations. If the call is ended within the grace period, no charges are applied. However, if the call extends beyond this period, all intervals are billed in full. With that clarified, we can move on to examining different interval charging methods, assuming no grace period is applied. If the call duration falls within the first interval, the total charge includes the connect fee plus the full charge for interval 1, regardless of the actual call duration. Following interval 1, the system applies the free seconds, if configured. During the free seconds interval, no additional charges accrue. Consequently, if a call duration is less than or equal to the free seconds interval, the total charge is limited to the connect fee and the full charge for interval 1. If the call duration extends beyond the free seconds interval, the charge for the respective number of intervals n will be added. Note that a call may end at any point within the final interval n. Although it is clear from the formula, to make it explicit, any interval, including the final one, is charged in full, even if the call ends before that interval is completed. For example, if interval n is 5 seconds and the call ends during the third second, the system will still charge for the full 5 seconds. Finally, a post-call surcharge may be applied if configured. This is an additional fee calculated as a percentage of the total accumulated charges, acting as a final markup to the overall amount. Combining all the individual charges we've discussed, we arrive at the general amount charged formula. In this formula, the number of intervals n is the primary variable. All other parameters are known values configured within the soft switch. Therefore, the total amount charged is essentially a function of the number of intervals n used during the call. Note that the price is divided by 60 within the formula. This is because the intervals are defined in seconds, but the prices are set as price per minute, so they must be adjusted to calculate the cost per second. The Sippy Softswitch follows the standard telecom industry convention of dividing calls into charging intervals. However, because call duration is measured and recorded in raw seconds, we need a consistent way to convert that time into the number of intervals n. To calculate this, the system first subtracts the free seconds and the first interval from the total call duration. This is because those initial segments are handled separately as fixed charges at the beginning of the call. The remaining duration is then divided by interval n, and the result is rounded up to the nearest whole number using the roundup function. This ensures that even a partial interval is treated as a full charging unit. Finally, the max function is applied to ensure the result never drops below 0, providing a clean, non-negative integer to calculate the amount charged. Combining the amount charged formula and the number of intervals and function yields a single equation where the amount charged is a direct function of call duration in seconds. For data analysis, this combined formula allows for direct calculation based on duration alone. Alternatively, the number of intervals n may be calculated separately and then used as an input for the interval-based formula. Both methods produce identical results, but the unified version is optimized for automated modeling where call duration is the sole input. In summary, the amount charged formula serves as the foundation for critical decision-making within the Softswitch environment. Accurate calculation of these values is essential for performing call profitability analysis, as it allows for the precise comparison of costs versus revenue on a per-call basis. Beyond simple accounting, this formula is a prerequisite for implementing advanced traffic management strategies. It enables margin-based routing, ensuring that traffic is only directed through carriers that meet specific profit thresholds. Furthermore, it provides the data necessary for a robust least cost routing (LCR) policy, where the system automatically selects the most economical path for every call based on real-time charging parameters. Mastering these calculations ensures both the financial integrity and the competitive efficiency of the voice network.